Well, good morning and welcome to the weekly pet pairing. I have a look in mind. I don't know whether it's going to turn out well because it theoretically looks good in my head. I'm taking my Glow Lust by Auric. So yesterday I purchased myself the Hinoki set from Sonia G. Kind of on a whim. It's not like I need more brushes, but these look just so beautiful, and what intrigued me the most about them, I think, are the shapes, because they are really interesting shapes. I don't know if you've seen them. If I don't forget, I'll put a picture somewhere on the screen. But there is like a really big fluffy brush. I've seen people use brushes like this for bronzer, and I've always been intrigued, but I don't actually have a brush in that shape. And the other brush is like a sort of like slanted blush, bronzer, highlighter sort of brush. I've seen Sonia use it on her Instagram for blush, and that is actually the purpose that I'm getting it for, so I'm really intrigued by it. But we shall find out. Taking my Hello. Every time I grab this, I want to call it the Hello Fresh Concealer. It is the First Aid Beauty Bendy Avocado Concealer, which to my horror turns out has been discontinued. So if ever this concealer is finished, because I still have this one and the Clarins one to go through, if ever finished, I'll need to find a new concealer that doesn't make my under eyes look like haggard bags. I don't know if that's an expression, maybe I just made it up. Anyway, so in one of my previous videos I mentioned, accidentally actually, that one of the things I'm currently doing at the lab is making kidney organoids. Maybe for context, if you've never been around my channel or you haven't caught that part, I work as a postdoctoral researcher in an academic research lab. I'm going to take my Estee Lauder Double Wear Nude Foundation, by the way, now. And the topic of my research focuses on these teeny tiny little structures that I may have mentioned before, that you may or may not remember. You probably don't remember because you don't need to store that kind of like useless information in your brain. But the lab that I work at studies a little cell organelle that is not exceptionally popular among scientists. It was discovered a really long time ago, but for the longest time scientists thought that it was a vestigial organelle and it didn't do anything until they found out that when it's gone, people get really sick. So the organelle that we study is called a primary cilium. And the cilium is like the little antenna of the cell. You might be more familiar with the motile version of the cilium, which is called a flagellum, like sperm cells have a flagella. But cells also have a immotile cilium. So it doesn't really serve as much the purpose to initiate movement or something, but it is present on most cell types in the human body. It has numerous functions which you don't really have to consider yourself with, but when proteins that localize to this organelle are missing or carry mutations in them, you get syndromic diseases called ciliopathies, and one that affects a lot of people is a kidney disorder called nephronophthisis. Anyway, it is irrelevant how the disease is called or whatever, but the important take-home message here is that cilia are very important for the proper functioning of the kidney. And one of the things that we study in our lab is the function of the cilium in the kidney. Obviously, we don't really have like kidneys to study, so usually we use cell line models, so that is just, cells derived from a certain part of the kidney that have been immortalized so that they can just grow and grow under culture conditions in the lab. And we have used a lot of those cell types in the past, but in the last couple of years, the latest rage in like fundamental biology are organoids. I wore this foundation yesterday with the Dior powder, and I didn't really like how that aged throughout the day. I feel like I like this foundation a little bit more with the Charlotte Tilbury, goodness gracious, this is a difficult one, Charlotte Tilbury Hollywood Flawless Filter Powder. So I'm just going to try that again today and see whether it really makes a huge difference. Anyway, before I tell you about organoids, we need to talk about stem cells, because that's where organoids come from. I think most of you will have heard about stem cells because they've been popular in cosmetic campaigns, in popular culture, pretty much like they've been a buzzword for a really long time. Most of the time they're used in completely like wrong context and to advertise things that are completely impossible to do with those cells. But for the record, they are cells that have a lot of potential, like a lot of therapeutic potential. And in some cases we've been able to harvest that potential, and in other cases not. But what exactly are stem cells? I've been on a kick with my Chanel Soleil Tendu Chanel bronzer, so I'm going to take that one again. So you guys know that you have a bunch of different types of cells on your body, right? You have skin cells, you have brain cells, you have photoreceptor cells, you have, like I mentioned, a bunch of different types of kidney cells. So in the first hours of your existence as an embryo, you were made of a little group of cells which are called totipotent stem cells. Totipotent because they can literally become anything. So take a stem cell like that and you can turn it into anything. It will turn into brain, stomach cells. However, as your body slowly formed, you know, and as you mature, and as all of your organs are formed, a lot of these cells become what we call terminally differentiated. So they become cells that don't really have the potential to become anything else. Like you take a brain cell and it's a brain cell. You cannot turn it into a blood cell. There are actually stem cells still circulating in your body. They're called pluripotent stem cells because they have the potential to become certain types of cells, but not all sorts of types of cells. For example, your bone marrow has a little pool of quiescent cells, like cells that don't really do anything. They're just like hanging there, and they only become active once they are needed. For blush, I'm going to take this beautiful Sukyu melting powder blush in the shade 05. There is a pool of cells in your bone marrow which are called hematopoietic stem cells. They can become any type of blood cell, but they cannot become a brain cell. And I think these sort of like pools of stem cells exist in other tissues and organs as well. I'm not super familiar with them though. I have to like give a disclaimer that I'm not at all a stem cell researcher or someone who knows a lot about it. But when I was talking, for instance, about therapeutic potential, hematopoietic stem cells are already being used therapeutically. So you can when a patient has, for example, leukemia or any other like myeloid disorder where you want to replenish their cells with healthy cells, you can take those hematopoietic stem cells and you can either take them from the patient themselves or from someone who is a immunological match, let's say. And then you can ablate the patient from their own blood cells. It's a very dangerous situation. Obviously, you have to keep the patient in very sterile conditions because obviously they will have like anemia and no immune system, and blood clotting will be a problem. But you can do that, and then you can ablate them of all of their blood cells, and then you can put new hematopoietic stem cells into their bloodstream to regenerate and repopulate the blood with hopefully healthy cells. So these cells are already being used for their therapeutic potential, but their therapeutic potential has remained a bit more limited than I think scientists had hoped for. Well, hello there. You can tell I'm not a stem cell researcher because I mixed up all of my terms. When I was talking about stem cells, I should have made it clear that they not only can differentiate into any other cell type, they can form a full organism. The hematopoietic stem cells I'm talking about are not pluripotent, they're multipotent. Because pluripotent stem cells are very much like totipotent stem cells. They can become pretty much every cell type in the human body, but they don't have the instructions to actually form a new body. So they're very powerful, but not as powerful as totipotent stem cells. I'm now going to take the highlighter from the Bridgerton palette, this one over here, because it has these yellowish tones that I think would fit with this blush from Sukyu very well. So the reason I'm telling you all of this is to make you see the potential that stem cells have. And as I said, scientists in the lab have been quite limited by the models they have because, like I said, the models they have are basically immortalized cells. And immortalized cells are nowhere near how an organ actually behaves. And obtaining stem cells, as you can imagine, is not something that we can just do. We could work with mouse embryonic stem cells, but as we have come to find out in all of the years that mice have been used as a, animal model, we have come to find out that a lot of things just work very differently in mice. Anyway, a couple of years ago, this Japanese dude came and make all of our dreams and hopes come true. And what he did was he took fibroblasts, and fibroblasts are just skin cells. He took fibroblasts and then he put what came to be known as the Yamanaka cocktail. So he introduced 4 genes into those skin cells that were able to basically perform this like jump back in time, so that these cells basically became stem cells again. And these types of cells are now very popular, and they are called induced pluripotent stem cells. So they have the potential to become different types of cells after we have induced them to become stem cells again. I hope that so far this is all like making great sense to you, because it's very hard to like do your makeup and talk and like remain on track. And also my husband was distracting me because he told me that he broke some of my flowers with his bike outside, which really upset me. Anyway, I'm going to take statuesque now. We're getting started on the eye look. So Yamanaka made all of our hopes and dreams come true by creating this model where we can take skin cells, and skin cells are more readily available obviously than human stem cells, and we can reprogram those at the lab relatively easily now in order to be induced pluripotent stem cells. And the years that followed after that obviously saw a surge in research of people taking those induced pluripotent stem cells and then using a variety of factors and years of research, very expensive research at that, throwing different sorts of chemicals at them in order to get them to become some sort of an approximation of a human organ. Now I want to make it clear, organoids are not organs. So when I talk about a kidney organoid, you should not imagine a full-blown kidney. We're talking about an approximation, something that is the best we can get under these circumstances without really having access to the actual organ itself. So people have been working a lot, and organoids have become quite the new rage in fundamental biology. People work on neuronal stem cell models. Some of my colleagues actually make cerebral organoids. One of my colleagues is making photoreceptors. The whole purpose of us making those organoids is for us to be able to study the cilium in a more like organ-specific context. You know, like a closer approximation than immortalized cells that you can grow in a culture flask. Because these organoid structures, they have like a 3D organization to them, and obviously when you grow like photoreceptors, they're nothing like the actual like eye or anything. You're not growing an actual eye, but they're just like the closest we can get right now to studying the cilium in a more, you know, biologically relevant context. The next shade I'm going to take is one that you probably have in your Decadence palettes, and I also have in my Decadence palette, but I also have it as a single, and that is the shade Lapis Luxury. And I'm going to take Lapis Luxury and hopefully be able to blend it a little bit here through my outer corner and crease. So I'm first going to take a little fluffy, like outer corner crease sort of brush. This is the Crease Pro from Sonia G. So for a project that I was put on in the summer of last year, I had to start learning how to make these kidney organoids, because luckily there is a lady in a different department from the one that I work that has experience with that. So I went to her and I learned the protocol, and luckily for me the protocol for making those takes about 30 days. So you take the induced pluripotent stem cells and then you basically throw a bunch of different chemicals on them. People have figured out like growth factors and different sort of chemicals, and I'm not going to go into the details of that because that is completely irrelevant to you, but you throw A, B and C on them and then they become kidney cells, or you throw F, G and L on them and they become cerebral organoids or something. It's a little bit how it works. Organoids that I'm growing to are basically a representation, more of an accurate representation, not of an adult kidney, but of second trimester fetal kidney. But they don't really reflect truly a developed adult kidney, and also they're like eeny meeny. They're like, I don't know, 3 millimeters or something. They're really tiny. However, microscopically speaking, they have all the different types of, you know, structures that you will find in the kidney. So they have nephrons, they have all the little structures that are present in a nephron, and obviously they're going to be a much more interesting model for us to study than cultured cells. The reason we're making these little kidney organoids is our lab studies not only the cilium, but we are also quite specialized in proteomics, and proteomics is basically the study of like proteins. And proteins are the workhorses in the cell. I think you have heard a lot about DNA and genes, but DNA and genes are just a blueprint for making a protein, and the proteins are the ones that do the actual work in the cell. And what our lab studies is how protein-protein interactions can be used to study the function of proteins with an unknown function, or to find novel proteins which are, you know, a part of our little structure called the cilium. And we go a little bit by the assumption that if you take protein X and then you find out what kind of proteins it interacts with, what kind of proteins are in its vicinity, you can deduce what the function of this protein might be if you don't know the function. And that is the case for a lot of proteins. For a lot of proteins, we have absolutely no idea what they do. We know that something goes wrong in the patient and it presents with a certain phenotype, but how exactly that happens is unknown. And the reason it's interesting is because if you know how a protein works, you may be able to develop treatments for these patients. My boss always likes to give the example of like Facebook, where he says, show me your friends so that I can tell you who you are. So it's a little bit how we study protein function in our lab. Show me your friends so that I can tell you who you are. So we are hoping to be able to study proteins that we are interested in that cause kidney disease in their, you know, natural habitat, in order to be able to find out what their function is and how could we maybe attack their dysfunction, and even use those kidney organoids as a model to explore those therapeutic options. And if you guys are still awake, to quote Martina Lilly, you are absolute legends. The next thing I'm going to do is I'm going to take my NYX glitter glue, and something unpleasant has happened to my NYX glitter glue, I noticed. It has popped open right here, so now when I try to squeeze out through the little hole, I think a bunch of it comes out through the big hole. Like, see, it's coming out of the wrong side. That is really annoying. I'm going to obviously be applying that onto the inner portion of my lid. To be honest with you, I don't feel like we need to apply lapis lazuli or more of lapis lazuli over a glitter glue. I'm just going to apply a little bit here towards the border and maybe reapply lapis lazuli over top of that. But I'm going to take just a tiny bit more of lapis lazuli and apply it here, all the way towards the center of the lid over top of that glitter glue. And then I'm going to clean off my brush really well, the little Crease Pro brush from Sonia G. Because I'm really lazy to take another brush, I'm just going to use that same brush and then go into the Bridgerton palette and take this beautiful chartreuse shade, because obviously I need to match my top somehow. And I'm going to apply that, as you've already guessed, into the inner portion of the lid. Anyway, I hope this whole story about the organoids made a little bit of sense to you, and I was able to tell it in a somewhat coherent and understandable way, because sometimes I think I'm explaining things in a very understandable way, but then people still give me the look like I have no idea what you're talking about. So, alright, next I'm going to grab my bronze Seduction palette, and I'm going to take this shade, the little golden sparkly astral, and I'm going to layer that right here on the center of the lid to marry the two shades together. And also, you know, because sparkle is absolutely mandatory in my life. Taking a small brush and the Skin Show shade from the Bronze Seduction palette as an inner corner highlight, because it is more of like a golden tinged champagne, so it will fit the rest of the look really well. I'm going to apply a little bit of Intensifies from Pat McGrath here on my lower lash line, and over top of that I'm going to obviously be applying more of lapis lazuli, because I just think it's going to complete the look really well without making it too complicated, and also lapis lazuli is just so glorious. I'm going to apply this Kiko eyeshadow stick in the number 11, which is a beautiful teal, I believe discontinued. but any teal or even lapis itself would work for this, just to put something in your waterline that matches Lapis Luxury. So that's it. I really love how it turned out. I paired it with a super easy peasy, easy breezy lipstick. This is Heyday from H&M. It's one of their cream lipsticks. And that is pretty much all. I actually quite enjoyed the combination of the chartreuse together with Lapis Luxury. Again, don't do your foundation and base makeup before you do this eye look. If you want to replicate it, learn from my mistakes. And just to go back to something that I was saying before and I forgot to mention again, to put things in context, when I was telling you that growing the kidney organoids takes about a month from the iPS stem cell stage to the finished product, I told you also that one of my colleagues is making photoreceptors. Those take 230 days. Just to give you perspective. So some of these protocols are very long and very elaborate, and I have a lot of respect for the people who probably like dedicated years and years, if not decades of their lives of trying to turn those iPS cells or those stem cells into any type of those organoids. I have no idea how they came up with like the specific, obviously it was an educated guess based on biology. We already know about the development of these organs, but just like figuring out all the things and what concentration to put them in and the timing of everything is just mind-blowing to me. Anyway, I've already done my first round of making kidney organoids and they were pretty successful. If everything goes well, I will be starting a new round of those tomorrow, so that will be Thursday for me. I don't know when you are going to see this video, but whatever, irrelevant. Anyway, I've rambled enough. I hope you enjoyed the makeup. Let me know what you thought about it. And I hope that you were able to follow a little bit of my science ramblings. And you know, if you were not, then I did a really bad job and I need to do better. Anyway, thanks so much for watching. I'll see you in my next video. Bye!